Solar, I would say, has been in its infancy. It's scaled dramatically. What we haven't done is optimized on the resiliency and the ability to control our own destiny. We can start gaining control of that, building local jobs, and the confidence that we control what we need in terms of energy supply.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about strengthening the domestic supply chain for solar panels. You've heard me talk about this a lot recently, particularly with storage. These new energy technologies may be cleaner and more sustainable, but can you build them within this hemisphere? As my guest points out, we seem to be offshoring our energy independence and national security at a time when the world seems a bit more unstable. My guest is focused on a piece of the solar panel that might not seem too sexy, the frame. Whereas more of the silica cells are being produced domestically, the frames are still coming from Asia. Building the frames here allows you to have a near 100% panel that's made in America. Most, if not all, solar panels are made with aluminum frames. You'd be forgiven for asking if switching to steel makes sense. Seems like it'd be heavier or rust after a winter or two. That's where the real innovation comes in. My guest says they have developed a cold roll forming technique to make these steel frames super light. He also says steel has historically been about a third cheaper than aluminum. But one of the benefits that we're seeing more nowadays is attention to how green this green energy is to produce. My guest says that recycled steel uses 85% fewer greenhouse gases to produce a frame as aluminum. These are just some of the reasons these stateside steel frames are a key to our energy security. My guest today is Greg Patterson, CEO of Origami Solar, a steel solar frame builder based in, appropriately enough, Bend, Oregon. Origami was founded in 2019. Greg came on early in an advisory role and has been boss since 2020. We spoke extensively about the need for domestic supply chains. Like me, most of you have probably considered yourselves free traders or pro-globalization. As Greg puts it, the pandemic in Ukraine have, quote, challenged the dogma. We also follow up on episode 34, which I did back in 2018 with the Solar Energy Industries Association. At that time, the Trump administration had passed tariffs on Chinese solar panels after the International Trade Commission had found China guilty of dumping. We'll update some of the recommended solutions after learning from that. I hope you enjoy my conversation with Greg Patterson. We're here with Greg Patterson, CEO of Origami Solar. And Greg, I've been talking about supply chains in almost every interview I've done in the past year. Help us set the stage when it comes to how our solar panels are sourced.
That's a great question, and you're right. It's almost hard to have a conversation without a supply chain topic coming up. The vast majority of solar modules or panels, they're interchangeable, are built out of what's called silica. The element that converts sunlight to energy is a silicon solar cell. Silica is one of the most abundant resources on Earth. I think I heard somebody tell me it's number 3 in terms of abundance, so it's widely available and ultimately is found in every continent in amazing supply. But they convert that into solar ingots or silicon ingots, ultimately cut into solar wafers and then impregnated with various materials to turn them into a solar cell. Very similar process to what is used in semiconductors on the front end. The reality of today, where solar is made is incredibly concentrated in China and some countries in Southeast Asia. So if you look at the solar panels themselves, really close to 80% of all solar panels come out of either China or Southeast Asia. And almost all of those are run by Chinese companies. It is a very, very concentrated supply chain. And what we've learned and all experienced in the last 2.5 years has been that concentration is not robust to perturbation and disruption with pandemic and other issues. As I said, silica is abundantly available everywhere, but the Chinese have focused their industrial policy strategically on multiple industries, solar being one. And so right now they have, over the last 20 years, co-opted and migrated to a virtual monopoly, which is really risky, especially for the US and North America. That supply chain, when you don't control your energy independence, you have no energy security, which is both a national security and just a quality of life, because energy, as we're finding out real time, is essential to the economic viability and quality of life of countries all over the world. That concentration is the issue.
Absolutely. And Greg, it's funny. It almost seems like more and more of our energy is being sourced with these international supply chains, right? I mean, it's good, I think, to diversify from oil and gas, for instance, but a lot of the oil and gas can be produced here. You look at solar cells, you look at lithium batteries. I go over this all the time. Supply chains running all the way around the world. That is a huge issue. Just logistical issues can become stifling, right?
Oh, it is. And when you have energy projects, be it oil, coal, natural gas, or solar, or wind, or batteries, you are impacting fundamental societal viability. Exactly. And that is what we're experiencing today. With the tragedy in Ukraine, we're realizing that we can be blackmailed. It doesn't require a natural catastrophe like a pandemic. You could take geopolitics that comes into adding risk to business continuity, which means societal continuity.
Absolutely. And that's one of the things I ask a lot of my guests is, can you build this product in the Western hemisphere, right? And I think more and more of my guests are kind of saying, yeah, we're working toward it. Okay, so let's get to what Origami is doing. They found a way, I'm told, to domestically produce the frames in a solar cells out of steel. In what way would that be new?
A couple of things. Let me give you more context on the solar frame supply chain. They're all made out of virtually all. There's probably somewhere they're not made out of aluminum and have been made out of aluminum, extruded aluminum for 40 years. It was selected because a lot of the early engineers came out of the aerospace industry, and aluminum was the material they used. It had pragmatic implications in terms of corrosion resistance and weight, but it really was almost the default. But we've been looking at what the industry and society needs. We realized we've got to shift this and find a solution that is dealing with the trends that are driving solar to continue to grow. I mean, solar is the lowest cost energy source in history, and it's been that way for several years, and it's just getting better and better. What we did is we figured out, how do we take this one piece of the solar system that has had no innovation in the 40 years since it was founded and bring real value to it? And one of those was that whole focus on energy independence and security, and how do we find a solution that will be cost effective and scalable to produce in every region of the world? And that's where we said steel is the ideal answer to that. The challenge is steel is much denser or heavier on a per volume basis than aluminum is. That's why aluminum's used in planes. But what we figured out is, how do you fabricate a frame using very thin aluminum to get the structural strength you need to protect that panel and mount that panel to your roof or to a bunch of racking out in the middle of a field for a utility scale power plant. And that's the trick and the innovation that we've brought, is how do you do it? And then how do you protect it with latest corrosion coatings? And so that is truly what we've done, is how do you build a lightweight, high-performance steel frame that actually outperforms aluminum frames that are shipped today.
And so the reason why you're called Origami Solar has something to do with the design of the frames. You're kind of folding it in on itself.
Exactly. Yeah. If you think about any structural steel beam, an I-beam and so forth, that profile or cross-section gives it unique strength and attributes to deal with the load it has to support. And so we did the same thing, understanding what a solar panel has to deal with, being it a bunch of snow in the northern climates or really heavy wind where it acts like a sail in hurricane or tornado-prone areas. How do you create that structural strength that will protect. What a solar panel is basically one or two pieces of glass that sandwich those solar cells, because it's a very fragile laminate. So it's a very challenging application. And steel is 1/3 the cost of aluminum and has been for decades. So we're going to a material that is 1/3 the cost, abundant regionally, lots of steel supply chain able to support the scale. And people don't realize that if I forecast the total frame lengths that we're going to consume in solar this year, it's over 4 billion meters. That's billion with a B a year of solar frames that are going to be produced. And the other thing, how do we reduce the carbon footprint? A lot of people don't realize that aluminum is dramatically more carbon intensive than steel. We'll reduce the carbon footprint of an aluminum frame, moving it to steel, by about 90%. So we'll be able to deliver a frame that's not only cheaper, stronger, but incredibly cleaner in terms of GHG gas content.
And can you just real quickly explain why aluminum is more carbon intensive to produce than steel?
I'm not the expert, but these numbers are not Origami internal numbers. We've engaged a very credible investor-grade consulting firm that literally does environmental impact analysis of how do you compare Chinese-made aluminum frames shipped around the world to domestically produced, ideally with recycled steel, which is abundant in both Europe and North America. And it shows a 90% reduction. And literally, it's from 90 kilograms of carbon, GHG gas, per frame down to 12 kilograms in the US made version. And these are literally credible. We've just published this report that we commissioned, and it is a third-party validated set of environmental impact.
Okay. Greg, I knew that China was producing a lot of steel. I did not know they were producing that much aluminum, that was all coming from China as well. So America has more of an advantage with steel and recycled steel, I guess, than it would be sourcing aluminum. Is that the idea?
Yeah. And fundamentally, the energy intensity of aluminum, which is really driving both the cost and the GHG, it is dramatically more energy intensive. I couldn't give you the detailed life cycle of aluminum, but the long travel and transit to the US or Europe is one piece, but it's a small piece. It is truly just that aluminum through the smelting and moving, I think, bauxite, that's the core. Aluminum is inherently dramatically more energy intensive than steel.
Yeah. Greg, I would assume that a solar panel from Asia, I'm talking about the whole completed unit, comes fully assembled with the wafers and the modules, the frames already sandwiching it together. So how does making just the frames domestically make the American supply chain for solar units, if you will, stronger?
First, you got to think about there's that 20% that isn't a Chinese-sourced panel. They're still buying their aluminum frames from China and shipping them here. They're struggling with the cost, both in terms of aluminum cost and shipping costs that have gone up dramatically. It's also their ability to have predictable revenue streams, because it doesn't take anything that's essential to that final product to not arrive on time to push out their revenue and ultimately their shipments to customers. So that's where it starts. And it kind of goes towards some of, I think, where we'll go to in this interview, and that is that we have to start building a more compelling industrial policy. In the U.S., for sure, we have to have an industrial policy that's going to rationally build that energy security and confidence that we can be self-reliant on both existing and future sources of energy that are essential. And so as we look at this and what we're seeing in the industry today, if you want to look at it from a national security perspective or just from a business continuity perspective, both the producers and consumers of solar energy are realizing that this concentrated supply chain is not the way we can continue to scale solar to support what the world needs going forward. To a large degree, it is all about how do we start building the footprint where domestic supply chains, including the frame and the silicon, are all going to be done within the region where they're going to be consumed, because that is a much more robust. Solar, I would say, has been in its infancy. It's scaled dramatically, and it's reduced the cost, total cost, by over 90% in the last 15 years. But what we haven't done is optimized on the resiliency and the ability to control our own destiny. That is what is the next, I think, real challenge for the industry. And Origami is trying to enable, be it in Europe or the US, we can start gaining control of that, building local jobs and the confidence that we control what we need in terms of energy supply.
Greg, that brings me right into the second half of all this questioning, which is how do you guys work with the cells, right? And in 2018, I did an episode with the Solar Energy Industries Association about the 30% tariff that was placed on solar panels at that time by the Trump administration. That was levied by them, but it was based on a Chinese dumping ruling by the International Trade Commission in 2012 during the Obama year. So did that jumpstart the American domestic production market for solar cells? I see there are about 9 manufacturers as of 2020, and I believe you said they have about 20% of the market right now.
Yeah, it didn't really jumpstart for lots of reasons, and it's all the political machine that occurs, especially in the good old US of A. They shut down a lot of the supply coming straight from China, but they started shipping out of Southeast Asia subsidiaries, and they've avoided those. So it didn't really stop the flow. And I think from a national security as well as everything else, you don't want to shut off a major source of your supply. It's a shame that we allowed China to concentrate like they did. What we have to do is develop a more sophisticated set of policies that deal with the national security implications of energy, for example, with solar, and really move past what I call the blunt instrument of tariffs. There's too many loopholes in our political system to allow escapes to come in the country and so forth like that. And really focus on how do we drive policy towards funding investment and rewarding the energy security practices of regional supply chains that can supply our needs is what we got to move to. And SEMA, the Solar Energy Manufacturing Association, has proposed some very compelling solutions to how do we economically and efficiently start driving domestic supply chain rebuilding versus just try to block imports.
Yeah. And look, I get the reason why they would want to impose a tariff. It didn't just come out of the blue. There was a ruling that said that they were dumping the panels, right? There need to be some sort of recompense there. Let's follow up on what SEMA had maybe recommended. How do you jumpstart the domestic industry here?
Well, I think tax credits to support domestic supply, government procurement, the DPA that the president announced, I think it was last week, are ways that you can do it. The DPA is a temporary fix, but you need to have congressional action on policy that really reflects the reality and risks that we are facing today. The tragedy in Ukraine that everybody, I'm sure, sees and hears about and feels for shows that we cannot allow any country, especially one that has a lot of orthogonal interests, control things. And so it is about building a policy, and there's a lot of ways to do it. And I'm not the expert in the policy side, but SEMA and others are. How do you deploy efficient policies that are not going to waste money, but drive the right investment to get that fundamental energy independence and thus energy security?
I think you touched on this a little bit, Greg. You guys are basically finishing up that last piece of the puzzle, producing the frames domestically where they would have to procure them from Asia. Does this complete the supply chain with the frames? Can you now build a complete solar panel in the United States, or let's just call it the Western Hemisphere?
Well, there's a lot of traction. In literally the last 6 months, we're seeing a lot more growth in announced capacity expansions. SEMA is trying to triple the domestic production from 7 gigawatts per year to about 22 gigawatts per year. We install in the U.S., I believe, around 32 gigawatts. So that would dramatically reduce the dependence on imported supply of solar panels. That is starting to happen, and I think it is. The pandemic and Ukraine is changing the dogma of the past of China's the only way to get cost reductions out and getting more to, well, we are already the cheapest energy in the world. Cost is not necessary to keep driving down. Let's focus on how do you optimize the deployment and the confidence and the business continuity of having diversified supply chains that really can provide the cost-effective solar that fits into our energy portfolio.
And your customers are these domestic producers of the solar panels, right?
We are looking worldwide and not just the North American piece, but that's where we're starting. And it's a perfect market to start because outside of China, the U.S. has really got the biggest supply chain left of domestically produced modules. Most of them are still sourcing from China on the upfront silicon wafers and cells. But for solar, they make a thin film solar cell that doesn't use silicon. And they are all domestically produced for their entire supply chain. But I think more and more companies are realizing that we got to move. And as we talk to these U.S. companies companies manufacturing panels, they love the idea. First and foremost, because they eliminate this uncertainty in the supply coming out of Asia of aluminum frames. That's one. Two, they love the carbon footprint improvements because ultimately we want to make clean energy like solar even cleaner. And then finally, the resonance with that energy independence message is really starting to play into the end buyers. Made in America is now making a much higher priority in the consumers that want to put solar on their roofs. It's like a perfect storm for us, is that all of these things are coming together and they can make a definitive move with the second most expensive part of a solar panel that makes it domestic, cleaner, and what we're finding out is higher performance because of the inherent properties of steel.
I think the other question might be, how competitive are we from a cost perspective with both Origami and the domestic module wafer makers here with what's being imported? Are we at parity yet, or is it still a little different?
Now we're projecting that we can provide a cost reduction by switching from Chinese aluminum frames to domestically produced steel frames. Plus, you get all of the supply chain risks that you can avoid and stuff like that. On the frame side, we are going to add value immediately. And as we scale this, that cost advantage will just continue to grow. We have a positive impact on cost right now out of the gates, but we'll also be able to grow that because they have perfected extruding aluminum for 40 years. We will have similar efficiency gains over time as scale and expertise and optimization comes into the steel solar frame fabrication and design.
You got to explain. How do you keep it from rusting?
There's a new generation of corrosion coatings that have been developed in the last 5 or 6 years that literally give steel incredible life because, these are all outside. And depending on where you're at, they have different challenges. But these new corrosion coatings are now commercialized, available worldwide, and can be very cost effectively applied. And they literally will probably exceed what aluminum can do in terms of corrosion.
Is there anything else besides the frames? I mean, it seems to me if you're already getting into that space, is there anything else that you see yourselves tangentially moving into as you grow?
I think we can add more value because with our design and the fabrication methodology called cold roll forming, we can actually add features to the frame that could help reduce installation costs as well as long-term operations and maintenance of the solar power plant's costs. So I think we're not looking at a new market outside of the frames. We want to tackle this one and get it figured out. But we are developing methodologies and design and intellectual property that we can move into other industries. But for now, as a startup, we're mission focused on making solar cheaper, cleaner, higher performance. And that value proposition coupled with domestically produced is really playing well in this world today.
I have no doubt. And Greg, I was looking at your profile. You said before we started the interview that you'd been an advisor with Origami, got asked to come on as CEO. I also saw that you worked as Chief Technology Officer for NLX, Enel, the major European utility. Tell us how that informed what you're working on now, because that certainly has been some interesting work experience.
You bet. No, my career path has been interesting. I started literally in nuclear with GE and then moved to Hewlett-Packard, worked my way up running large worldwide divisions for them and their printer group. And then I got passionate about renewable energy. My first startup was a very small company. I think there's 10 people in the company that I took over that was making solar inverters and was successful, learned a lot. Got humbled deeply from going from that classic ivory tower of big corporate life to a startup in a garage. And we were able to turn that little inverter company into the number one commercial inverter producer for North America. That company was called PV Powered. We sold that to a multinational named Advanced Energy. But while I was at that inverter company, I realized that the next thing that's going to enable renewables to be a no-compromise solution for the future energy needs of the world, it was going to be storage. And how do you control and integrate batteries into the grid and couple them with renewable sources, microgrids, non-renewable sources, because they provide the essential ingredient. And that company, which was called Demand Energy, was bought by Enel. And ultimately, as they did further acquisitions after ours, I became the CTO to bring several different companies together and integrate their offering to scale the solutions across the world through NLX. And I kind of retired after that, but a good friend, Eric After, the founder of Origami, asked me to come help him think through this idea, and I got enchanted with it, and I saw the promise, and ultimately he decided that you've done this before, I haven't, so why don't you run it? Because we all want this to succeed, and I appreciate his confidence in me. So it's kind of an interesting career path from big companies to small companies to successful exits of previous companies, and planning on doing the same thing here.
Very exciting. All right, Greg, I'm going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
Great foundation element now. It is most valuable in the ability to deal with the peaks and dynamics of the worldwide grid. Ultimately, batteries are probably provide a better solution and more cost-effective solution as batteries scale, but it has been an incredibly cleaner bridge to where we need to go long-term.
Crude oil.
It is foundation to so much of society today in transition and unfortunately available to the broad world from countries that make it challenging.
Nuclear.
Has the promise to be everything if we could ever solve that waste issue. It does give us tremendous capability, but we have eons of challenge on the output.
Coal with carbon capture.
Challenge in terms of just the fundamental economics as an energy source. And clearly with the carbon capture, if that could ever be perfected and scaled, and I think the scalability of carbon capture, where do you put it, is the biggest challenge I see there.
Wind.
It's great. Absolutely great. It's really been able to scale and so forth. Clearly a core element of the future energy portfolio.
Solar, you guys.
Clearly my favorite. It's the most scalable, lowest cost, and best matches, not perfectly, but best matches classic demand profiles that utilities around the world are dealing with.
Biofuels.
Great concept, but we also need as much food as we can get. And I'm not sure I want to convert potentially food sources, either for animals or people, into that if we don't need to.
Hydroelectric.
Wonderful, incredible, but limited number of opportune sites.
Geothermal.
Wonderful solution to the portfolio, but again, there's geology that says it's not scalable.
I heard you talk a little bit about this. Sounds like you're a big fan of this too. Energy storage.
Absolutely. It's the key. What people don't understand is that the growth in electricity consumed, you can think of it as gallons of electricity, isn't growing that fast, especially in developed countries, but it's the dynamics. As more and more luxuries like air conditioning come on and more extreme weather are causing challenges in extreme heat or extreme cold, both of those, storage gives you the perfect shock absorber. Scale and the need to use rare earth elements is the limiter. But the theoretical value of storage is huge.
Energy efficiency.
It's where you want to start. We got to reduce the waste. And that's a fundamental that we got to continue to push. It may not be sexy, but it sure is essential.
And then finally, fusion power.
If we can solve that, we can all sleep easier.
All right, Greg Patterson, Origami Solar, thank you so much for your time.
Well, thank you very much, Jay. It was wonderful talking to you, and I appreciate the time and interest.
That was Greg Patterson, CEO of Origami Solar, a steel solar panel frame manufacturer based in Oregon. I want to thank Greg for his time, as well as Sinead Carthy at Trevi Communications for setting this up. I last worked with Trevi on one of my panelists in episode 130. You can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 143. Be sure to join us next week when we learn how batteries are being designed virtually by the same company that built the 777 on computers. Until then, I'm Jay Downhauer. We'll see you next time.